We go to the third question. In the given figure, G is the point of concurrence of medians of triangle DEF. Take point H on ray DG such that G lies between D and H and DG equal to GH. We have to prove that quadrilateral GEHF is a parallelogram. Now they have given a figure here where they are saying that G is the point of concurrence of the medians. You can see here the three medians of the three angles of this triangle are meeting at the point G. So it is the point of meeting or the point of concurrence of these medians. Now they are saying to take a point H on ray DG. So there is a line from passing from D to G and further onwards. You have to take a point on that called H such that G lies between D and H. So obviously H will be on the other side of DG and DG equal to GH. So if you measure this distance and this distance, it should be the same. So DG equal to GH. Now what have we to prove? To prove that quadrilateral GEHF is a parallelogram. Let us see how we do it. Let the median from vertex D, okay, this is the median from vertex D. It is intersecting the side EF, okay, that is intersecting, it is meeting this side EF. We write here EF at which point? At point M. So we write here at point M. Now this G, they said, is the point of concurrence of the medians, and the point of concurrence of the medians is called the centroid. So we write here G is the centroid. Further, the centroid divides each median in the ratio. Now this centroid type of sum we have already done earlier, where we had said that the centroid of a triangle divides each median in the ratio 2:1. That is, DG is to GM is equal to 2:1. So we write it divides each median in the ratio 2:1. Therefore DG is to GM is equal to 2:1. Now 2:1, if I were to write this ratio in the form of decimal, that is DG upon GM, it would be 2/1. So if I write like this, 2/1. Now in the next step, if I take GM on the opposite side, what happens? DG is equal to 2GM. 2GM upon 1 is 2GM itself. So here DG becomes 2GM. Now I have here DG is equal to 2GM. Okay. Also they had given something about DG. What did they say? DG is equal to GH. So they have given DG is equal to GH, that is given. So we have two things about DG. One, that DG is equal to 2GM. Other, DG is equal to GH. Now look at this GH. What is this GH made up of actually? GM plus MH, right? We can add GM and MH and it becomes GH. So, but GH is equal to GM plus MH. So now considering all these three, DG equal to 2GM, DG equal to GH, but GH is equal to GM plus MH, we know that GH would be 2GM. But in place of GH, I can also write GM plus MH, right? So I can say 2GM is equal to 2GM is equal to GM plus MH. Now why have I written this? I have two terms now with GM. So I take both of them on one side. That is, I write now 2GM minus GM Okay, taking this GM on the other side is equal to MH. So what happens to GM? 2GM minus GM. It's like 2x minus x will be 1x or just x. So we write GM is equal to MH. Now look at the figure. We have GM is equal to MH. We have proved that GM is equal to MH. But what is this GM and MH? You can see that this is the parallelogram which they said, that is GEHF, and GM and MH, they are the parts of one diagonal, that is GH. Also, if you look at the other diagonal, that is EF, we know that EM is equal to MF. Now how can we say EM equal to MF? They had already said that M is the midpoint of this side EF. How did it become the midpoint? Because this DM was the median. Median is a line which is drawn from a vertex to the opposite side, which divides the opposite side into two equal parts. So EM equal to MF. So now see here, we had just now got GM is equal to MH. So we can write segment GM congruent to segment MH. Also, segment EM is congruent to segment MF. So I write here segment MF. What did we say is the reason? That M is the midpoint. M is the midpoint of segment EF. So if we have that, look at the figure, segment GM congruent to segment MH and segment EM congruent to segment MF. What is happening actually? It means that the diagonals are bisecting each other, and we know one of the theorems is a quadrilateral is a parallelogram if the diagonals bisect each other. So we can say now, therefore, quadrilateral GEHF is a parallelogram, and write the reason. A quadrilateral is a parallelogram if its diagonals bisect each other.